agree with me, let us go ahead and introduce ourselves. I want to start with the UNICEF and partners team. John Paul, Bob, could you please introduce yourself and then continue with the water mission team?
Okay. Good afternoon, everyone. My name is John Paul, the Wash Sector Co-Coordinator. I'm with Bob right now, so he's just stepped out of the room, but we are sitting on the same desk. Back to you.
Thank you. How about others? I see Baba, I see John Jeffrey, Mohammed.
Good afternoon, all. I'm Mohammed Abdurrahman Lawan from IOM, Wash.
Thank you, Mohammed Abdurrahman Lawal.
Good afternoon, I'm Baba Musami Sharif from Solidarities International, Wash.
Thank you, Mr. Baba. I see John Jeffrey now. Harriet. Okay, maybe we can continue. For the water mission team, my name is Daniel Maizama. I'm one of the two Solar Hub advisor for West and Central Africa. I'm currently based in Niger. I want to give the land to my colleagues, Manuel, Sam, and Jordan. Please, over to you.
Thank you very much, Daniel. I'm Manuel Tayo. I'm the second regional advisor. I'm based in Burkina Faso. Thanks. Sam, Jordan.
Good afternoon, everyone. My name is Samuel Knobloch. I'm a project engineer with Water Mission, and I'm based in Charleston in the United States.
Good afternoon. My name is Jordan Deshawn. I'm also a project engineer with Water Mission based in Charleston. And it's a pleasure to be on the call with you all. Back to you, Daniel. Maybe if there's anyone else who wants to introduce themselves.
Yeah, I'm still coming back. John Jeffrey Harriet. If you are hearing us, it's over to you. And I see BBM the guest. I don't know who's that.
Good afternoon from Maiduguri. This is Bob joining the call, sitting in with John Paul. It's a pleasure to catch up again.
Thank you so much. I see Michael. Michael is just joining the call. Michael, welcome.
Thank you very much, Daniel. Colleagues,
you have the plate to introduce yourself, please.
I'm Michael Forsen, Wash Manager, UNICEF Abuja. Thank you very much.
Thank you. Is there anyone who is still lagging behind on introduction?
Hello, good afternoon all. My name is Bilal. I'm a Wash Activity Manager, Solidarities International. Thank you.
Okay, that's good. Thank you so much. Okay, I'm seeing another addition, Sakuzwa.
Good afternoon.
Yes. Takuzwa Mushamba.
Takuzwa Mushamba.
Okay, thank you. So thank you everyone for attending this this webinar. Thank you everyone. I'm sorry that was the intervention. Thank you everyone for attending the webinar. I'm gonna give the play to Mr. Samuel from Water Mission, who's going to do part of the talk about the different things that are involved in this meeting. So thank you so much, Sam. Over to you.
Thank you, Daniel. Thank you, everyone, for attending this webinar. You're most welcome. I'm very excited myself to have this opportunity to share some of Water Mission's expertise, especially in terms of installation of solar-powered water systems. So what we plan to do today is just to look together at some different pictures that were sent to us to inspect the quality of solar-powered water system installations. We can look through the pictures, talk about the different notes that we've made, and see what we can learn. So I think this is the first webinar that Water Mission has done in this way. We only have 1 hour, but I think and I hope that there will be plenty of opportunities for future 1 hour webinars similar to this, where it can be a relaxed setting. It can be an open discussion. We would love it to be an interactive discussion where we can hear everyone's responses, questions, comments, and we don't need to worry about getting through the full agenda in 1 hour, because we can always set up an additional opportunity for future webinars. So yeah, that's all I wanted to say, and maybe at the end we can save 5 minutes or so to discuss what would be most helpful for everyone for the future, and what you would like to learn in the future. So with that, let me get started. So we were sent pictures. Oh, first let me share my screen here. So we were sent pictures of many solar-powered water systems in Nigeria to kind of do a site inspection of the water system installation. Specifically, 7 of these projects had sufficient information contained in the pictures to begin assessing the water system. The first thing I'll say is it really the best way to assess the quality of a solar-powered water system installation is to be there on site, to be on the ground, to be able to look at everything closely. But it's still very helpful, I think, to do an assessment through pictures. If that's all you can do, we can still get some good, valuable information. So these 7 projects we received some pictures, and ideally for doing assessments of future installations or of any installation, the more pictures that can be shared, the better. And the more detailed pictures and at many angles, then the more feedback can be given about that installation. Imagine yourself on ground. If you were analyzing a water system, and every single detail you might look at, and every glance you would take at all the different parts of a water system, and imagine trying to contain everything you see in the form of pictures, you would have to take a lot of pictures at many different angles. Each object, you may want to see every side of that object. So similar for doing an assessment by pictures, you can never have too many pictures, but we'll take the pictures that we have, we'll discuss what we see, and please feel free to jump in, to interrupt as I go along. I will not be offended. I would love to hear questions and anything people have to say about what they are seeing. So we'll start with site number 4. This is a goal prime project. And I'll read my notes that I made, and then I'll go through and show you in the pictures. So you can see I have my notes here on the right side, and then some pictures that I'll go through on the left side of the screen. So the first thing I noticed about this installation is there are no pictures shared of water treatment. So even for water sources of very good quality, it's recommended that chlorination be done as water treatment. And the reason for this is even if the water is free from contamination in the source, the water will likely be contaminated by pipes, by tanks, or by the people who are collecting the water. Maybe it will touch their hands, their containers. There's no guarantee that everything the water will touch from the time it is extracted to the time it is used will also be clean. In fact, it's likely it will not be clean, and then it can contaminate the water. But chlorine gives the water a residual protection from contamination, and it's safe to drink, so that if the water touches dirty hands, it will still have some amount of protection to make it safe to drink. So Water Mission recommends that it's chlorination as disinfection and residual for all water system installations to ensure that safety. This is also a common standard in municipal water systems all across the world for public water to have that that residual, some kind of protection from contamination. So now let's look at the borehole. This is the borehole. You can see the well is here, and the pipe comes up out of the borehole there. So some comments I have for this installation is, number one, there should be a water meter installed on the project. It doesn't have to be installed at the borehole. Maybe there's a pump house or near the tank, but a water meter should be installed on the project and be in a protective box. Let's go to some more photos. Here we go. Let's look at the tank tower. So one thing I noticed about the tank tower is the piping is not adequately secured. So the piping up and down to the tanks, it does not run along a support and is not strapped to anything. So the ideal installation for suspended piping is that it would be against a wall or a tank column or against the tank to provide support, especially if it's plastic piping. And then it should be strapped with pipe straps or some other kind of something to secure it. And this would protect it for the long term and give it more durability. The second thing is I would recommend is having some kind of fence around the tank structure. This will reduce the risk of accidental damage to the piping or anything else. It can prevent, it can also prevent children from being able to climb on things where they would also not be safe. Let's continue. another comment I had about the piping going to the tanks is you see it for the inlet to the tanks, the piping comes up and divides and branches to go to both tanks. The way I would advise this to be done is along the base of the tank tower. So if the inlet pipe could divide here and branch and go to the base and then run up the tanks into the inlet, that would also be more secure for the pipe. Basically, the goal is to limit the amount of suspended pipe that is not secured to something or is not running along some kind of support. The less you have of that, the more secure your pipe system is going to be, and the more you reduce the risk damage. Let's look at the solar power and the wiring for the system. You can see here's an example where the pipes do run along a support. So that is actually recommended for all the piping as much as possible to run along those supports. Even if it requires a few extra elbows or a few extra fittings or additional length of pipe, it's worth it to for the protection of the pipe. Okay, so here we go. I'll go back to the beginning. Okay. So one thing you can see in these pictures is that the solar array is completely flat. So there are two things to consider when you're determining the tilt angle of a solar array. One is the location of the project, specifically the latitude of the project, and what will give it the best direct sunlight. So if you are 3 degrees north of the equator, then if you face, then you may want to consider facing the solar array south by 3 degrees to get the most direct sunlight. However, the minimum tilt angle for a solar array, Water Mission recommends to be 15 degrees. And the reason for that is for cleaning. If the solar array is tilted, when there's rainfall, the rain can wash dust off of the solar panels and help them stay clean. If the solar panels are completely flat, despite the fact that that might be a little more efficient for capturing solar power, it can also capture water. Rainwater can pond on top of the array, or it won't wash any dust away because it's too flat. So Water Mission recommends at least a 15-degree tilt. Another thing I've noticed about this solar array, I'm gonna zoom in a little bit, is there's one solar panel that is different from the other solar panels. You can see this one is smaller in size, so that indicates it's probably a different model of solar panel and probably a different amount of power. So the reason this is a concern, well, first of all, the details of this specific solar panel was not shared, so I'm not 100% sure what the electrical specifications are, but it's very important that the solar panels that are installed and wired together have the same electrical specifications. If solar panels that are wired together in series, they all have to run on the same electrical current. So if you have one large solar panel wired in series with a small solar panel, then both solar panels will run with a low current because they have to operate with the same current. If you have 10 large current solar panels installed in a string with one single small solar panel, then it will cause all 11 solar panels to operate with a small current because they all have to match each other's current. And it's the same with voltage. When solar panels are installed in parallel, they will all operate on the low voltage. So this will, so basically, you want to avoid having solar panels of different electrical specifications because it will reduce the efficiency of your array. The larger solar panels will be operating at a low amount of power, and you won't get as much solar power from your array. So that can raise the question, what should you do if you need to replace a solar panel and you can't find the same one? You try to match the electrical specifications as close as possible, specifically the VMPP voltage and the IMPP current, to limit the amount of inefficiency in your system. Does anybody have any questions about that? Okay. Another comment I had that I already touched on is fencing. Especially solar arrays that are installed low to the ground should be protected by fencing. It's very easy for the solar panels to be damaged in some way. They're not protected by any kind of covering because they have to receive direct sunlight in order to operate efficiently. So they can't be covered themselves with any kind of protection. So the best thing to do is have fencing around them. In our experience, all kinds of debris can fall on them, or children can throw rocks, or anything can damage them. So it's best to have fencing, number one, to prevent damage, and number two, to prevent theft. Finally, about the solar rack is the frame. You can see there's a good amount of rust on the solar frame, and over time, the rust will continue to eat away and deteriorate the solar rack, making it weaker. The best way to prevent this is to paint all the steel framing at the time of installation, and to repaint probably once every 5 years to continue to protect the solar racking from rust. So now let's look at some pictures of the electrical installation, talk about wiring. So this is the pump control room, or this is the inverter. It appears to be installed in the pump control room. So one thing that would be great to see is pictures of the entire pump control room. So all the wiring can be seen. Everything that's installed inside this room can be seen. And then we can analyze that. But one thing I'm getting from these pictures is, although you can't see much wiring, it doesn't appear to be installed in conduit. Also, even if you go back to the solar rack, you can see this is some wiring here. So all Water Mission recommends that all pump cable, all solar cable be installed in conduit, and the conduit should be secured to, once again, secured to a support or secured to the wall, something like that. This protects from Water damage, it protects from insects. It protects from someone tampering with the wiring. And it helps keep people safe, especially those who may not know much about electrical power and how to stay safe around it. So, and it protects the equipment as well. Even when electrical equipment is installed inside a room, it's best to protect with conduit as much as possible. Another comment I'll make is it is recommended that an electrical room like this be used for installing all of the electrical controls on a water system. It protects from water, insects, all that. It keeps the equipment protected, and the more protected the equipment is, the longer it will last. And hopefully by the end, we'll get an opportunity to look at some installations that show kind of the full recommendation for protecting electrical equipment that we make. So next, I want to move on to another project and look at more pictures. But before I move on, does anybody have any questions or comments they would like to share?
There is one question in the chat box. Can you see it, please?
Yes. So, will the fence posts cast a shadow on the solar panels? It's a great question, Jordan. Let's take a look at the solar panels. Yes, so depending on the time of day, it looks like it's quite possible that these fence posts would cast a shadow on the solar panels. I don't know which direction the sun is rising from. It looks like there's a slight tilt to this. At the back, it looks raised, and at the front, it looks lower. So let's assume that this is the south side of the solar array. So that would be the ideal direction to tilt the solar array. Then in the morning, as the sun rises in the east, that would be the right side of the picture. These poles could shade the solar panels, and in the evening, as the sun is setting in the west, these poles could shade the panels, and that would cause a reduced production. So I think it is likely the sun is very high in the sky. So during the day, I wouldn't expect the north and south poles to shade, but regardless, anytime a solar panel installation is done, it should be clear from any possible shading obstruction. Trees, other structures, fencing, all that should be constructed in a way that it does not shade the solar panels. And during installation, it should be observed while things are being constructed. You should observe to make sure that no shadows are being cast. Tree branches can be trimmed, but if you structures cannot be trimmed or moved, so that needs to be adequately planned. Any more questions?
Hello?
Yes.
Yeah, for example, like this one has one of the solar panel different.
Yes.
Assuming all the solars are mono and then you got a replacement of poly, is it okay?
That's a great question. I'm not extremely familiar with all the differences between mono and polycrystalline. So one difference I know is that I believe monocrystalline is less prone to deterioration over time. But I'm not extremely familiar with the difference. But one thing I'll say, the most important thing is that the current and the voltage of the panels be matched or very similar. But I would have to get back to you on whether it really matters if it's mono or polycrystalline. Jordan or Daniel, do you have any, or Manuel, do you have any insight for that?
No, I think we can try to investigate and then respond back with that question.
Great. Yeah,
It was a
we'll
great
make a note
question.
of that. Absolutely. Okay, so let's move on to our next site I want to talk about. This is a CRS project. It's called Crs Borehole 2. So let me pull up my notes and let me pull up the pictures for this project. Okay. So the overall quality of this installation was good, but there are some areas for improvement. So we'll talk about that. The first comment again, at least based on the pictures that were shared, there was no water treatment installed on this project. So again, oftentimes borehole water quality is very good, but we always recommend some form of residual prevention from contamination. And chlorine is the simplest. It's the easily accessed solution for that. So let's open up some pictures. First thing I'll talk about is the solar installation. As you can see, the solar panels are at more of an angle of installation. It's hard to know the exact angle of installation. It may be a little bit too shallow for good cleaning by rainfall. Another thing we see here is that the wiring for the solar panels is secured neatly underneath the solar panels. They're not hanging loose, which is good. I know I talked about all wiring being inside conduit. That excludes the solar wiring that is immediately under the solar panels. So really, when you have these solar panels wired individually, the best thing to do is to tie them. Zip ties, cable ties are the best way to do that. Keep them secure to the bottom of the rack. And then when they come together or when they begin to run toward the electrical room, they should enter conduit before coming out from under the solar rack. So the conduit should maybe start from underneath the solar rack and then run wherever it needs to go. Some areas of improvement for the solar rack. Number one, the supports, you can see they're not all perfectly straight. They're welded off of the railing from the tank support. So the supports don't look perfectly stable or quite stable. The most important way to improve the solar rack support structurally would be to add cross bracing in between all these vertical supports. That would make the solar rack much more secure, much more structurally sound. Wind blowing can cause it to sway, and cross bracing would prevent that swaying. And then I might the cross-bracing may be sufficient to really make it secure, but I also might prefer having larger vertical members for these solar arrays. And the best thing would be, if it's going to be on top of the tower, for the vertical support to go from the solar rack down to the tower base rather than being connected to the railing. Just to make it sound. So, and then the other comment I would have is that it's best to install solar racks on the ground or on the roof of a structure where the solar racks can be easily accessed. So because these are installed up high, even if someone comes up to the tank platform, it is still very tall for them to be able to access. And also the tanks may prevent access to fix wiring or to do any kind of repairs or maintenance, and especially cleaning. So imagine being the person who has to go up and clean the solar panels on top of this tower. There's really no place to stand. There's no place to put like a ladder on the base to get up there. So that is why it'd be preferred to be installed on the ground or installed on the roof of something where it's safe to stand on the roof in order to get to the solar panels. Or it's safe to put a ladder somewhere on the roof and easily access the solar panels. So that's something to be considering is, can my solar panels be safely accessed for cleaning and repairs in my installation? And you can use your best judgment for that as well. So that's those are my comments on the electrical installation. Let's see if I can. Let me talk more about conduit. Let me see if I can find a good picture for that. So this is the borehole. As you can see, the electrical wire is not protected in any kind of conduit. Again, we recommend that conduit be installed, and also ideally here you would have a structure around the borehole. If there's any plastic pipe or plastic conduit or wiring exposed, a small masonry structure can be constructed around the borehole to protect that wiring, the conduit, the plastic pipe. Otherwise, galvanized pipe, because of its strength, it's acceptable to install outside of a borehole. But you wouldn't want to have long runs of unsupported galvanized pipe. A borehole structure can also check the water meter as well. I think, see if there's a close picture of the. So as you can see, the pipes running up and down from the tank are also suspended, not secured to a support. Ideally, it would be secured to a support. I've seen where the pipe is strapped to the vertical support of a tank tower, and then a hole is made in the platform so the pipe can come up and go to the tanks rather than doing elbows over to the outside, but both are acceptable. The key is to have the pipes strapped along supports for durability. And it also appears that this is the pump cable coming down from the solar. There you can see a small cable here, this thin line looks like the pump cable. And it should also be, it's very important that it be strapped in conduit, and then that conduit be strapped to a vertical support. So the key thing to remember is that all wiring should be in conduit and not exposed to damage by animals, by insects, by lizards, or by any other accident that may happen. Water Mission has seen a lot of cables that have been chewed by lizards, even on our own projects. So we have learned over time to protect them as much as possible. Let's see. Some positives. The water system is installed within fencing, which is good to protect the project, and borehole piping is very straight. The horizontal runs are level and the vertical runs are plumb, and we have straight 90-degree turns. Those are all good things. The use of metal piping when it's exposed is good. So it looks generally, it has a look of neatness to it, although there is some exposed cable. Any comments about this system or any questions? One thing I'll say is we haven't seen, this project doesn't show where the pump control switch is. So that is something, I'm not sure where that is and how the wiring is done there, but we'll look at some other examples to talk about that. Okay, so I'll move on to the next water system. We have about 15 minutes, so maybe we can do one more water system, and then we try to get through that quickly. And then if there's time, we can look at a water mission installation and talk about some things as well. So let's see. The next borehole I want to show is CRS Borehole 1. CRS Borehole. Photos. So again, another comment is about water treatment. I didn't see any water treatment for this project either. But we've discussed that. So this is the project. This is where most of the components of the solar powered water system are contained. And I think this is the location of the borehole there. So we'll talk about the electrical installation first. Some good things. You can see again, the wiring is secure underneath the solar panels. But once it is wired together, it should go into conduit. The solar rack has cross bracing, and it is at the footing. It is encased in concrete, so it has more stability than the previous solar rack because of the cross bracing and the way it is tied into the ground here with concrete. Ideally, this area, it was hard to see, but this area should be fenced in so that people cannot just access the solar array, the wiring, the switch. All this is exposed, and you can see there are taps here. So I'm assuming this area is open to the public, which means the solar component in the tanks ought to be fenced off just to keep things protected. So let's look at the electrical switch. Actually, from this angle, you can see that this might be a wire splice or something. You can see where it's hanging down a little bit. So ideally, that could be improved, more secured. Okay, so here's the power switch for the pump. So the best way to install the power switch would be inside some kind of electrical room or a very small masonry enclosure with a door so that it is protected from outside damage. A rock could hit this or something, or just over time, it is exposed to the weather. I'm not sure if it's sealed from water. So when rain would hit the outside of this and maybe moisture could enter. There's no conduit going into the entry, so it doesn't appear, like you can see that the entry into the switch is not sealed. You can see an exposed wire here. The copper is not exposed, which would really be a concern, but even this it opens up the system to potential damage. All like wire splices and wire connections. Let's see where we can see that connection. It looks like this connection may be a splice or something. All wire splices or any kind of connection should be made in a should be protected somehow, either by, and not with just electrical tape or even with just like a heat shrink, but it's best for it also to be inside conduit or inside conduit and even inside the electrical control room. Of course, if wires are joined at the solar array, then at the very least they should be inside conduit and done with a waterproof splice, either by heat shrink, a proper heat shrink seal, or there's also what is called a waterproof splice kit, where an outer coating seals the splice after the splice is made so that water cannot enter. And then that should be protected inside conduit. The recommended switch, this project is a Grundfos SQ Flex pump. The recommended control switch for that would be the CU200. The Water Mission recommends that all SQ Flex, standard SQ Flex pumps be installed with the CU200. It gives a lot of information about the way the pump is running. So it's better than just controlling with an on-off switch. You can install a tank level switch. You can see error codes if the pump shuts off, various things like that. And it's relatively inexpensive compared to the cost of the pump. It may be about 10% of the cost of an SQ Flex pump. So for an additional 10%, you get a lot of value. Then finally, the piping. You can see some good things about the piping is almost all the piping runs along something to help it be secure and not just open and unsupported. You can see here, it runs along the side of the tank wall before it enters. Here, the piping runs up the tank, up the wall, and then across the floor of the base and up this support. That is good. The way I would improve that is to add pipe straps. I wouldn't add pipe straps to the tank itself. You don't want to make a hole in the tank, of course, but to add pipe straps where it is against the concrete. And then also the valves, we recommend the valves be installed in a valve box to prevent them from damage that would cause leaks. See if I have any other notes.
Sam, sorry to interrupt. We've got a question from Baba. Baba, please go ahead.
Okay, Sam. My question is, you made mention that CU200 is the recommended control box for the SQplex. But I'm seeing various people using just control box or on and off switch. Is there any short-term or long-term effect of that?
That's a great question. So it does depend on the switch used. Grundfos has specifications that need to be met for an on-off switch for their pump. So you would need to make sure it meets the specifications. But there is no risk of damage or anything like that. As long as the on-off switch is properly rated, then it's, I would say, an adequate switch for operating the pump, and there's not a risk of damage. But I think the CU200 adds some extra benefits that we recommend as valuable. Of course, whoever is maybe the project manager or engineer on the project can make that final decision, of course, but it would be my recommendation because of the value you get, the information that a CU200 can show you about the pump while it's running, I think is valuable. It shows, it has a tank level switch, it has error codes, it has, it can show you the status of the dry run sensor, and it also shows you the amount of power that the pump is being that the pump is consuming while it's running. So you can see if a pump has adequate solar power by looking at the CU200. Things like that, I think, add a lot of value. But just an on-off switch, if properly rated, is an acceptable operation for the pump.
Okay, thank you.
You're welcome. So it's 9:58 now. That was the last water system I really needed to get through, I think, to show everything, show the main points that I looked through. But there's a lot more aspects to discuss. I think solar powered water systems there's a lot of material to be discussed in general, so we can never run out of things to discuss on future webinars. I think we can begin to wrap up, but I'd like to hear maybe from John Paul or others if they believe this was helpful exercise, if we should plan to do it again in the near future. If there are other things you would like to discuss that we didn't include in the scope of this meeting before we close. And there'll be plenty of other opportunities to give feedback. If no one has immediate feedback, that's fine.
Yeah,
we can
from my
discuss
side
it.
it's okay. Hello?
Yes.
From my side it's okay, but one thing we need to discuss is the sizing of the form. I am seeing various comments for the 7-side access. Maybe if we can talk about the sizing of the form and then the discharge or yield of the borehole, and then related to the solar panels and what have you. Thank you.
Great. Yeah, some other, that's a great comment. Like I said, there are so many aspects. Sorry, just one sec. Aspects to solar powered water system. There's design, there's installation. We can look at existing installations that as positive examples. We can look at things that need to be improved, all that. Is there another comment?
No, from my side.
Another thing that can be looked at, we can look at what some water mission example installations as well, and talk about the different standards we have in our own installations too in the future. So all those are ideas. Basically, I just want to communicate that Water Mission is here to support Nigeria, and whatever you feel would be best help you to learn and would best support you to do excellent installations. We would love to offer our help. So I think I will, does anyone else have more comments? Maybe Amadou, I see you're unmuted. I didn't know if you have a comment.
No, I think for me, I feel like it's timely, and for us, we are open to such kind of enlightenment. You know, it's improve what we are doing. Even though these are things that we already know that it's not supposed to be like that, but sometimes we overlook it because of the fact that we just want to achieve our targets and report to donors. So I think having you on board with us and reminding us, I think is very, very important, and it's something that we wish we could be having it more regularly, so that it's just like a callback, a kind of refreshing, and then ensuring that people are working with that. Thank you.
Welcome. You're welcome. We would also look forward to having more things like this. Yes.
Yeah. Can you hear me?
Yes.
Okay. So mine is a comment and a question. I think this is a very good meeting that it's highly beneficial to us here in the Northeast response and in Nigeria in general. So I just want to ask if what should be the best practice, as you can see from the examples you've when you shared your screen and discussed about almost all the connections, the pipe connections from the wellhead to the tanks. The storage tanks are more of a PVC. So which one should be the best practice for the exposed pipes? Should it be the PVC or a GI pipe? Thank you.
That's a great question. So at the wellhead, I think there are two options for what is best. You can keep it as GI pipe, or use PVC pipe within the wellhead. But the key is if PVC pipe is used, it should be, then the wellhead should be enclosed in a masonry structure. And I would say the most ideal situation is that the borehole be enclosed in a masonry structure either way, if possible. So that you can open up the steel door and you can see the different things inside the borehole at the wellhead, but you don't see the pipe. But I think just if there is no masonry structure, then GI and like the water meter and maybe other plumbing pieces should be in the pump house or somewhere where it's protected. Yeah, so then as far as like pipes, all plastic pipes should be buried. The one exception is where pipes go up to the tank. Of course, they'll come out of the ground, and we recommend that it either be GI or like a UPVC PN16. And it needs to be UPVC because UPVC is protected from UV damage. So just regular PVC over time will become weak from in the sunlight. If it's a steel tank, then GI pipe is the best. But using GI pipe for a plastic tank, it can also be problematic because the plastic tanks expand and contract when they fill with water. And so the rigid GI pipes will pull on the tanks while they expand and contract, whereas the PVC pipes are less rigid and they don't have that issue. So if it's a plastic tank, then a PN16 for that extra thickness in the pipe would be recommended, and it should be strapped to a vertical wall as well. So I think that's all the time we have. Of course, we look forward to future discussions, whether it be design or sizing, solar power, or selecting the right pump, or any aspect of installation. We look forward to discussing in the future. Buhari, go ahead.
Okay, thank you very much for all this. I'm one of the participants that we attended the training in Abuja with the water mission team, and which is together with my colleague. We are trying to see how we can also give support to our colleagues in the Northeast. Actually, my question is just, but I think at the end you already answered. So just to understand, the main concern for either selecting the GI or UPVC pipe is we are considering the weakness. With time the UPVC is getting weak. So I think basically during the design of the waterworks, I think the engineer on site, or maybe the person that is designed, he can consider maybe like the location, the location and other climate factors there, and also like you mentioned that with the extra thickness, that's a PN16 UPVC. So this is just my question is why I say maybe at the end of your this thing you already answered the question. So it can come maybe into our during the design also we can maybe the engineer on site, he can take care of all those things, because at times also GI people don't want to use GI because of the corrosion immediately. As long as there's a little leakage along the pipe, you see that within a very short period of time, then it can become weak also.
Yes. Yeah, those are some very good points, Buhari. Even UPVC over time will weaken in the sunlight. So an additional protection for UPVC can be to paint it. And like you said, the GI pipe, if there's a little leak, it does corrode. So there's benefits and weaknesses to both sides. And so like you said, the engineer can consider those things and make the best decision. Yeah, exactly. So yeah, that's all the time we have. I know Chris Cope helped set up this webinar. He communicated that he would love to make this a regular thing, and that we'd just love to be available to help in the best way we can. And please give us feedback about which specific things you'd like to learn about in future webinars, and what would be a good frequency and duration of the webinar, whether 1 hour is good, keep it short, or more time. We can always adjust. So Daniel, I'll give it back to you for closing.
I think Daniel had to jump off, so I might step in here. Again, as Sam said, thanks so much to everyone for participating. I just want to quickly highlight our website through the West and Central Africa Regional Solar Hub. It's wcarsolarhub.org. You can visit this website to see a bit more information about us, but the main thing to highlight here is that if you need technical assistance or have questions or requests that you would like us to assist with, you can click this button here, and that will take you to a different web page where you can fill out a form, enter some information, your country, so that we can respond to that request. Additionally, another way to reach us is to contact us via this email, which is wcarsolarhub@watermission.org. So we look forward to hearing from you. And as Sam mentioned, we look forward to hosting webinars like this in the future. Thank you again, everyone, so much for participating. And I hope you all have a great rest of your day. Thanks so much. Bye-bye.
Thank you. Bye-bye.
Jordan. Bye-bye.